Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing tree topic and the pattern was DFS. Today we will do the next question, which is count complete tree nodes. So let's read the problem statement. It says we will be given the root of the binary tree. Make sure it's complete binary tree. Okay, why? Because this definition will help us to identify something that we'll talk later. Our task is to return the number of nodes in the tree. Okay, so basically we have to count the number of nodes. It's very easy, but the question is key design an algorithm that runs in less than O of n time complexity. So we all have covered this count number of nodes type of problem, similar in the previous problems as well, but there we did with O of n, correct, with time complexity. But here we have to check if it is possible to count the number of nodes, just the number of nodes in less than O of n. Also, as it is a complete binary tree, so for sure the nodes in the last level will be as far as left as possible. The definition means key as it is a complete binary tree, so definitely it will have left node also and right node also. So if a tree, what is a complete binary tree? Either it will have 2 children or 0 children, or if it has 1 child, then for sure it will be left child instead of right child. Okay, let's read the constraint. It says the number of nodes will be 0 from 0 to 5 into 10 power 4. Okay, so 5 into 10 power 4 is nothing but that n which we consider in time complexity with big O of n. Okay, so we have to basically reduce this n here in the time complexity. Okay, let's see. So from my perspective, the question is very simple. If you don't know any optimized approach, with the most lenient approach means O of n, how can we count that? And that was very easy. You first start with the root. If you are present at root and that root also exists, okay, if it is not null, then we can say na ki count this as 1, correct, and bring the count from left side and bring the count from right side and then add it up, means left count plus right count and plus 1 for this current node, correct, and the same formula we have to apply for each and every node, correct. So as it is a DFS, why DFS? With BFS also you can do. Okay, in queue append every node one by one, and you remember level order traversal in BFS we did already. So there in the queue we will append node one by one. First 1, then popped, count 1, then append 2 and 3, pop and count plus for 2 times, so total count will be 3. Then append 4, 5 as the children of 2 and 6 as the children of 3. So append all this in the queue, 4, 5, 6 and later pop. So in total the number of times you have popped the nodes, that is nothing but the total count of the nodes. Yes, but there the space complexity we will be using extra O of n to store the values on the queue, which is not even required, right? So that is why here we'll prefer DFS instead of BFS. Okay, so now from DFS how can we do? If we are at root, definitely we say na ki 1 plus left count and plus right count, remember? So for this left count, can I say I'll call the recursive function with root dot left this time? Similarly root dot right for the next time. Okay, similarly left, right. Okay, so first you will go from 1, you will go to 2, because left call, DFS left call will get called first. 3 will be waiting, right call will be waiting. Now from 2 again left call means 4. Now again from 4 left call, now it is null. So if the root is null, what do you think? What should be returned? Because 4 is expecting any integer value from left side and right side, so that 4 will add 1 extra to that counter saying this is the total number of nodes from this side. What did I said? Key after DFS call I'll be somewhere here at 4. So 4 will be calling left side and right side, and 4 is waiting for left count and right count. Remember 1 plus left count plus right count, that should be an integer, so that 4 will add 1 to it saying ki total number of nodes are this much from this side. So can I say if root is null return 0? Yes, because 4 will get 0 from left side, 0 from right side, correct, and 1 plus to it because 4 is there, right? So 1 plus this. So in total 0 plus 1 plus 1, 1 will get returned to 2's left. Can I say? Similarly 1 will get returned to 2's right. So for 2, 1 plus left plus right, remember, again it is 1, left is also 1, right is also 1. So total 3 will get returned to where? 1's left side, correct? Now similarly from 1's right, here left, this will return 1, then this will return 2. So in total, for 1, left is 3, right is 2 and 1 itself. So total 6 will get returned. But if you saw, the time complexity was O of n. Why? Because we went on each node to count number of subnodes, right? So that is not expected because the question itself mentions ki design an algorithm that runs in less than O of n time complexity. Less than means we have to think for something logarithmic. Yes, because less than linear means logarithmic. Okay. So when it says log, for sure we know in tree log_n is nothing but it is like when we talk about levels. So in tree, how level helps? Can I say level is nothing but the height of the binary tree as well? Yes. Okay. One more question. Here though we don't have any node. Suppose we had, okay, suppose we had 7 here. Suppose, okay. What is the height? Can I say number of levels? 1, 2, 3. Again, I'm saying why I thought for level approach, because the question mentions ki less than linear approach time complexity it is expecting. Less than linear means logarithmic. Logarithmic means log_n means something near around levels. Levels means height of the binary tree. That's how you have to think for the optimized approach. Okay. So 3. So can I say 3? Okay. So 3 means, and we all know ki 3 is height, and if every node has 2 children, so we can say 2 power 3. So 2 power 3 is nothing but 2, 4, 8. And what is the number of nodes? 7. So minus 1 to it. In this case, so this formula correct. But what about next one? Suppose this, and one more. Okay, one more. Here number of levels are 4. So 2 power 4 means 16 minus 1, 15. Check, is the count is 15? Yes. Why? Because see 2 power 2, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. So 8 plus 4 plus 2 and plus 1. That is why, as it is always 1, so that's why we do always minus 1, because 2 power 0 is 1 only, not 2, right? So that's why. So can I say if I will be able to count the number of levels, means height, then with this formula I can actually count the number of nodes. But is it true for every case? I don't think so. It is true only when all the nodes were present. Remember, here though 7 was not there, then how would we consider? Because here though height will say ki 7 is also there, so total number of nodes are what? 7. But like 2 power 3 minus 1, 7. But this node though was not there, so how we will get to know ki at what level we don't have the child? Here comes the definition part. How? If you remember, definition said ki it is a complete binary tree. So for sure it will have left child and right child both, or else it will have nothing, or else it will have left but it won't have right child. Can I say that? So when it has both left and both right, can I say left and right children are equal? Then though I can say yes, height will help. How? Just listen. When left and right, we have both children, means still left and right are equal. When we say we don't have left or right, then we can say ki still left and right are equal. But when we have left child, like in this case 3, we had left child but we don't had right child, there we have to think differently. Okay. But here, let's say, suppose it had 7. So the task is very simple. Ki tell your left side to bring your level. Tell your right side to bring your level. So this left side will say my level is 2. So the number of nodes I will have is this. Can I say? Which is 3. So left side will say ki I have 3 number of nodes. Similarly, this side we will get what? Height is 2. We have to calculate the height as per the left nodes in left subroot and as per the right nodes in the right subroot. So in this case, as 7 was not there, so when we will divide this, it is waiting for number of nodes from left side. Why I was waiting for number of nodes? Because I want to calculate if my number of levels from left side is equal to number of levels from right side, then I can consider my what? Then I can consider my number of nodes. Okay. So it's very simple. From here I want to calculate left height. So left height will be 1, 2, 3. How? As per the, I am only counting if I have root dot left, okay. So here left height is 3. Now I want right height. So right height is 1, 2, but here as the right children is not there, so the height is only 2. So hence the left height is not is equal to right height. It means for sure some nodes are missing, correct. So from this level, so we cannot say ki what is my child, okay. Now again, what we'll do? We'll break this into two parts, like this part and this part, okay. So wait, as my left was not is equal to right, remember when it was not is equal to right, then only we considered what? Ki return total count, but 1 plus. Why? Because from here only left count and right count was not equal. So what I am saying, break this into two half, left half, right half, and then count me also na. So that is why 1 plus left plus right. Can I say that? Okay. Left and right is nothing but you can say go towards left side and right side. Okay. Like this is DFS call. So let's say some DFS call with root dot left and a DFS call with root dot right. Okay. Now what will happen? We'll go towards this side. Now for this call 2 is the root, correct. So again we'll call the left height will say 1, 2, and right height will say 1, 2. So hence in this case left height is equal to right height. Na? So what I am saying ki in this part we don't need to break further. We just need to count, which we already count, left height and right height both were equal, and that is nothing but my height of the tree also. So 2 power 2 minus 1, this will directly give me the actual answer, which is 2 power 2 4 minus 1 3. Okay. So hence from this part I have directly got 3 as in my answer. Okay. Now I'll go towards right side. Here left part has returned 3. Now for right part. Again for right part this is the root. So from here left height is 2, but right height is only 1. Correct. Again these are not same. So again 3 will say 1 plus go towards my left side and go towards my right side. Correct. Now for left side, for 6, what is the left height? 1. What is the right height? 1. It is same. So 2 power 1 minus 1, which is 1. So it will give 1 from left side. Now from right side, as we have nothing, so it will return 0. So in total 1 plus left plus right will return 1 plus 0, 2. So 2 will get returned to one's right side, and one's left side, so we just taken how many time complexity to calculate the height? Can I say log_N only? So it will get returned only in log_N, correct? 3. So 3 plus 1 plus 3 plus 2, total 6. Now what is the time complexity actually? So from left side, to instead of taking n number of time, we just took log_N just to calculate the height, correct? Similarly for right side also, but right side we broken down into two halves. Why? Because this side was not equal to this side. But how many times we will do this? If you see this clearly now, because it is a complete binary tree, so this where the node is not present now, this will only happen like this type of tree where it is not complete, you will only see in the last level, for sure last level. Like it cannot happen ki there it won't have any children, it won't happen. Okay, so hence this definition is only possible at the last level. Okay, so can I say till last level this side will return in just log_N. Okay, because it was so complete na. Again suppose we have tree like this, okay, like bigger tree. So here also it will have, here also it will have, here it won't have, correct? Here it won't have. So this, like when we divided this part though is correct, it's complete. So it will give, like we don't need to break it further. It will give the answer in just log_N. Just calculate the height, because for this left height is equal to right height. Can I say that? Similarly for this, again the definition was not true. Okay, so we have broken down. Again this is so correct. So this will give me in just log_N. Again this is not correct. Okay, again break it. So for how long we are breaking it? So if you will see this clearly now, we are actually breaking it for nothing but the number of level times. Because in the last level also only it will be like untrue. Like this, Like you will have left child, but you won't have right child. So this will happen only for the last level. So I can say na ki for every level I am doing this, and level is nothing but log n. So hence log n multiplied by log n, which is log of n square time complexity. If this is clear, then I'm going to write the code for you. So here is a basic code. First, the base check if root is null, so returns a 0. It won't have anything. Otherwise, what is the condition? Calculate the left height and calculate the right height. Okay, left height and right height if you calculate, and if these are equal, then you don't need to break it further. You just need to return by this formula key, like 2 power is nothing but if you will do the shift operator, left shift for height many times, then you will get the exact. Like I hope you know this key 1 left shift left time left height time is nothing but 2 power 3 only if left height is 3. Okay, otherwise if they are not equal, then you know na key 1 plus we have to break the left half and the right half. So again we will call this same function recursively. Now we'll make the left height and right height function for us. Okay, so we will write private, return type will be integer, function name we'll get root, right? So type will be tree node and root, correct? Our task is to calculate the height. So we will initialize int height is equal to 0, and now we have to give the left height. Okay, so until our root is not null, we have to do this. What we have to do this? We have to calculate height here, and we have to move our root but only towards left side. Why? Because we are counting the left nodes, correct? And after coming outside, we just have to return the height. Done. So this was for left height. Similarly, we have to do this for right height as well. Okay, correct. So left height will count the number of left nodes but from the leftmost perspective. Right height will give me the right side height but from the rightmost perspective. So for this the right height will be only 1 and 3 because 3 does not have any right child. So hence it will not get counted, and in total we just have 2 heights from the right side and 3 height from the left side, as they were not equal. So that is why it is important to break them down. Okay, so the time complexity to calculate the left height is log n, to calculate the right height is log n, correct? So as we are doing this one by one, so this is the O of log n and O of log n in plus, so it is 2 log n. But how it is log of n square? Because first you took log n, and then here further you are breaking this down when the left height and right height are not equal. That is making it nested. Okay, so hence log of n square is a time complexity which is far better than linear approach, and it is smaller also. So let's run the code. Did I missed something? Okay, sorry, my bad. Here we have to shift right side, right? Until we have, okay, done. Now let's submit this. Okay, as you can see it is faster also. So the space complexity was, if you know, you are only saving the levels, which is nothing but log n, in the stack calls, because you are recursively calling it but not for every node. So you are calling it for every levels. So hence log of n is the space complexity. So this is the code in Java. If you understood this, here is the code in C++ if you are from C++ background, and here is the code in Python if you are from Python background. So if you understood this, and I'm expecting you will submit on your own, then definitely you are eligible to go in the sheet and mark the next question as done. So I hope you all understood, and you will definitely comment down ki yes you understood or yes you submitted, because that will give me more motivation to make more such videos for you all. And that's it. Hit the like button and subscribe the channel if not yet subscribed. Let's meet in another video. You will get the sheet link and my social media links in the description. Till then, keep learning, take care of yourself and your family.